In 1802, a pharmacist named Luke Howard looked up at the sky and decided clouds needed names. Cirrus, cumulus, stratus, nimbus. Suddenly, the sky was not just something humans lived under, it was something we could classify. But more than 200 years later, people are starting to ask if these categories are changing. Are the clouds above us still the same clouds that we used to know? Or have we changed the sky so much that even the clouds are starting to behave weirdly? The answer is yes, but also it's complicated. Clouds are not only honorary mashed potatoes, they're also Earth's temperature control system. During the day, many clouds reflect sunlight back into space, which cools the planet. But clouds can also trap heat, especially high, thin clouds that let sunlight in and then slow down heat trying to escape from Earth's surface. Low clouds, like marine stratocumulus clouds over the ocean, are especially important. They reflect sunlight away before it can heat the surface. So clouds can either cool or warm, depending on what kind they are, how high they are, how thick they are, where they form, and what type of day they show up. This is why clouds are one of the hardest parts of climate science. They are small compared to the size of the planet, but huge in their effects. They form from tiny particles, humidity, temperature, wind, oceans, smoke, land, forests, pollution, dust, and they can change within minutes. One of the biggest reasons clouds may be changing is that the planet is warming. Warmer air can hold more water vapor. More water vapor can mean more fuel for clouds and storms. But it does not simply mean more clouds everywhere. Instead, it changes where clouds form, how intense rain becomes, how long dry spells last, and how much moisture is available in the atmosphere, so the sky can become more intense in both directions. So maybe the clouds are changing because the entire machine underneath them is being rewired. And then there's the question of cloud cover itself. Some recent research has suggested that Earth's reflectivity, or albedo, has been unusually low in recent years, partly connected to fewer low-level reflective clouds in certain regions. Albedo is just a fancy way of saying how much sunlight a planet reflects. Ice has high albedo. Dark ocean has low albedo. Bright clouds can have high albedo too. So if Earth loses some of its bright reflective clouds, more sunlight gets absorbed. And that can add extra warming, which could be a problem because if warming reduces reflective clouds, then warming equals more warming. This is called positive feedback, and it means the system is reinforcing itself. But scientists are still working out how much of this is long-term climate change, how much is natural variation, and how much is connected to other human changes like pollution. Because here's the plot twist. Pollution can actually make clouds brighter. Tiny particles in the air called aerosols can act as seeds for cloud droplets. For decades, pollution from ships, factories, and burning fossil fuels may have helped create brighter clouds that reflected sunlight back into space, actually masking some of the warming. As air pollution rules have improved in some places, the atmosphere has become cleaner. And that is definitely good for people. Breathing clean air is definitely nice, but it may also mean that some clouds are less bright than they used to be, which, as we've just learned, can contribute to the Earth warming. But this doesn't mean that pollution is good. It just means that the climate system is way too complicated to have easy, simple takes. And then there are clouds that humans create directly, contrails. Or, depending who you ask at a family barbecue, chemtrails. These trails are white streaks that form behind airplanes when hot, moist exhaust meets very cold air high in the atmosphere. Sometimes they vanish quickly, but under the right conditions, they can spread out and become thin, cirrus-like clouds. They can affect how much heat stays trapped near Earth. So in some parts of the world, the sky isn't only changing because of climate, It's changing because of airplanes. Cities can also influence clouds. Urban areas absorb and hold heat differently from forests, fields, and wetlands. This is called the urban heat island effect. Warm air rises, and rising air can help clouds form under the right conditions. Cities also add particles to the air, change wind patterns, and replace natural surfaces with concrete and asphalt. That means that local cloud formation and rainfall patterns can shift dramatically around urban areas. And then there's the factor of land use. Deforestation, draining wetlands, planting crops, building suburbs. All of this changes how water moves between land and air. Plants release water vapor through transpiration. Forests can help create humidity and influence cloud formation. When landscapes change, the air above them can change too. Clouds are connected to what happens below. A cloud is the visible part of a much larger conversation between ocean, land, heat, plants, pollution, and air. But here's the part that makes this question feel personal. People often notice things before they can prove them. Someone might say, "The summers feel smokier now." Or, "Storms seem different." Or, "The sky just straight up doesn't look like it used to." And sometimes memory exaggerates. And clouds change. They've always changed. That's kind of their thing. But the world beneath them has changed too. And our sky is not separate from us. It's a living record. It remembers what we put into the air. It responds to what we do on the ground. And maybe that's why clouds themselves are so interesting. They're not just clouds. They're fluffy little pieces of evidence. They're the atmosphere thinking out loud, and we should probably listen to it. Liked what your weird brain just learned? Hit subscribe. If not, that's okay. You can leave, but the clouds are coming with you.